Welcome back to Aurora Tech Channel. Today, we're going to test the AnyCubic Kobra X. At first glance, this looks like another Bambu Lab A1 clone, just like the Creality Spark Xi7 I reviewed a few months ago. I didn't originally plan to review this printer, but many viewers did say they wanted to see it. At the same time, another machine I had planned to review was postponed due to some technical issues, so I decided to test the Kobra X as a substitute. According to the price tracker on my website, auroratechchannel.com, the Kobra X usually fluctuates between $279 and $349, depending on when you buy it. So, let's take a look at what this machine offers in the entry-level price range. It is a bed slinger with a print volume of 260 by 260 by 260 millimeters, which is marginally larger than the standard Bambu Lab volume of 256 by 256 by 256 millimeters. The motion system uses a linear rail on the x-axis, steel wheels on the y-axis, and dual linear rods and lead screws on the z-axis. Unlike the Bambu Lab AMS Lite, which comes with a separate stand and requires a printed mount if you want to install it on top to save desk space, the Kobra X integrates everything into the print head. You simply mount 4 spools of filament on top of the frame. The biggest improvement compared to other AMS setups is the hot-end design. As you can see, the cutter is placed right above the heat break. As a result, during filament changes, after the cutter cuts the filament, the remaining filament inside the heat break and nozzle is only about 33 millimeters, which is much shorter than other setups. It's 46% shorter than the Creality Spark Xi7 and 32% shorter than the Bambu Lab A-series machines. This significantly reduces purge volume, saving both filament and print time. The maximum nozzle temperature is 300 degrees Celsius, and the bed can heat up to 100 degrees Celsius. It comes with a double-sided PEI sheet. For other features, it has an HD camera and an LED light. Belt tensions can be adjusted using a hex wrench. There is an RFID reader for AnyCubic's own filament, which can automatically set the filament type and color. It also has expansion ports that allow you to connect 4 additional ACE2 Pro and print with up to 19 colors. When using cloud printing, you can also control the printer and monitor prints through the mobile app. If you do not trust cloud services, you also have the option to print over your local Wi-Fi network. It supports both 2.4 GHz and 5 GHz networks, and you can also print completely offline using a USB drive. It uses AnyCubic Slicer Next, which is basically AnyCubic's skinned version of Orca Slicer and supports all the features of the printer. You can also use the regular Orca Slicer, but it does not support network printing with this machine. I would like to thank AnyCubic for sending us this machine to review and for sponsoring today's video. As always, even though this is a sponsored review, we won't hold back from pointing out any issues or drawbacks we encountered during our testing. With that said, let's get started. The machine came in a compact box. On top, there is the build plate and some accessories. In the middle, there is the gantry, and the base is packed in the bottom layer. At first glance, it does not look very different from a typical bed slinger, except it has 2 dual spool holders mounted on top of the frame. Putting this machine together is straightforward. First, place the gantry on top of the base, then tighten the screws from the top instead of the bottom. After that, install the 2 covers on the base. You still need to flip the machine over to connect some cables, and there is another cover for the bottom as well. The nozzle wiper is installed on the left side of the machine. Finally, mount the spool holders and connect the Bowden tubes to the print head. Now we can turn on the machine. It starts with language selection, followed by region selection. Then it scans for Wi-Fi networks. It supports both 2.4 GHz and 5 GHz networks. After entering the password, it connects to the network. For the cloud service, I will skip it and just use the machine on my local network. It reminds you to remove all the protective materials, which I already did. Then it starts the calibration process, which takes about 35 minutes. It begins by heating up and performing PID tuning. After that, it runs input shaper calibration. One thing I noticed is that both the print head and the bed move during vibration testing, which I assume helps better simulate actual printing motion. Then it performs a 7x7 bed leveling process, followed by motor noise cancellation. Okay, the calibration is now done. I will manually load 4 spools of filament into the machine. Since I am using random brands of filament without RFID, I have to select the filament type and color manually on the screen. Okay, now the printer is ready to print. Let's move on to the slicer. Since AnyCubic does not fully support Orca Slicer, you can add the printer to Orca Slicer, but you cannot send prints directly to the printer over the network, even when it is running in LAN-only mode. So in this case, I will use AnyCubic's skin version of Orca Slicer, which they call Slicer Next. They changed the device tab to Workbench. On this page, you can log into your cloud account, but if you are using LAN-only mode like me, you can manually add the printer to the slicer using its IP address. The printer's IP address can be found under Settings, LAN mode. Once I enter the IP address, the printer shows up here. Let's start with my first color benchmark, the 4-color square. Looking at the default profile speed settings, the maximum speed is set to 300 millimeters per second, and the outer wall speed is set to 200 millimeters per second. Travel speed is also 300 millimeters per second, but acceleration is a little slower, ranging from 2,000 to 6,000 millimeters per second squared. The estimated time for this print is 1 hour and 20 minutes, which is much faster than other single nozzle AMS setups, which normally take around 2.5 hours. As you can see, there are 75 color changes on this small print because every layer uses all 4 colors. On my first try, the result was not good. The skin color looked okay at first, but after switching from gold back to skin, the color became contaminated. Looking at them side by side, this is definitely not the correct skin color anymore, which suggests the purge volume for the gold filament was not enough. Since I am using random filament brands, I had selected a light yellow color for the gold filament. As you can see, when switching from yellow to skin, it only purged 125 cubic millimeters because the slicer assumed the light yellow was close to the skin color and would not contaminate it much. However, the actual filament is gold, so it requires much more purging. In that case, I selected a darker yellow and let the slicer recalculate the purge volume. Now the purge volume has increased from 125 to 550 cubic millimeters, making this the highest purge volume color change, even higher than blue to white. Because the purge volume increased, the total purge waste also increased from 17 grams to 27 grams, and the print time increased by 14 minutes. So let's see how it prints this time. You can see that bed leveling is only performed on the top left area of the print surface because we only have the purge tower at the top left and the model in the center. It seems the first layer of the golden skin colors is slightly too squished, but still usable. For now, I will time the color changes. The first change is from white to skin, and it took 42 seconds. Next is skin to gold. Which took about 10 seconds longer at 51 seconds. From gold to blue, it took 54 seconds. Then it switches from blue to skin, and I expected this to take longer and purge more because it is switching from a dark color to a light color. This change took 1 minute and 22 seconds. Then from skin to white, it took 46 seconds. It seems the slicer intelligently avoided switching directly from gold to skin, which requires the most purging. Throughout the print, I did not see any direct gold to skin changes. The print finished in 1 hour and 34 minutes, closely matching the slicer estimate. Let's take a look at the filament usage. For purge waste, the slicer estimate was 27 grams, while the actual purge waste was 31 grams. The model itself was exactly 5 grams, and the purge tower was 5 grams compared to the 3.74 grams estimate. Let's compare this print with other machines. I compared it with the Bambu Lab A1, A2L, and Creality Spark X i7. In terms of filament usage, there is no big difference, but I believe the shorter heat break on this printer should save more filament on larger prints, so we will see. In terms of print time, the Kobra X is faster than all of them. It is 22% faster than the A2L and 39% faster than the A1. It is also 30% faster than the Spark X i7. When compared to the dual extruder Bambu Lab X2D, the X2D saves 43% of purge waste because the second extruder prints one dedicated color. Of course, a tool changer like the FlashForge Creator 5 is better than any AMS setup for multicolor printing. In terms of print time, surprisingly, the Kobra X is even faster than the X2D, which is really unexpected. However, a tool changer still wins by a large margin in print time. Next, I will expand my Hello Kitty army by printing 4 of them. The 3MF file was sliced using red as one of the colors. Even though I am going to use pink filament instead of red, I will keep the slicer settings unchanged to ensure the purge volume is sufficient and remains consistent with the tests I performed on other machines. This print has 314 color changes with an estimated print time of 14 hours and 14 minutes. The print finished in 14 hours and 17 minutes, just 3 minutes longer than the estimate. As for filament usage, the purge waste, model weight, and prime tower were all very accurate, almost exactly matching the slicer estimates. All 4 Hello Kitties printed beautifully without any noticeable color contamination. Let's compare it with other printers. In terms of purge waste, the Kobra X actually uses about 16% less than the Bambu Lab A2L. However, the slicer settings result in a slightly heavier model, so the total filament usage is about 3 grams higher. Compared to the Elegoo Centauri Carbon 2, the Kobra X reduces purge waste by 45%. It also saves 32% compared to the Creality Spark X i7. In terms of print time, the Kobra X is faster than any other single extruder AMS setup I have tested. When compared to more advanced machines, like the dual extruder Bambu Lab X2D, the X2D reduces purge waste by 63% and finishes the print about 12% faster than the Kobra X. Multi-hot end systems like the H2C and tool changers, such as the Snapmaker U1, still have a clear advantage over both single and dual extruder AMS setups in terms of both filament efficiency and print speed. Next, I will print the Vegeta model. He is the Prince of Cyans and the King of Color Contamination. I will stick with my original 3MF file, which uses a darker yellow for the gold filament. This should provide sufficient purging when switching between the gold and skin colors. This print has 247 color changes with an estimated print time of 6 hours and 11 minutes. The print finished successfully, but I noticed that the brim on the right side was once again squished a little too much. The total print time was 6 hours and 14 minutes, just 3 minutes longer than the estimate. The purge waste, model weight, and prime tower weight were all very close to the slicer estimates. Let's compare it with the latest single extruder AMS bed slingers. Compared to the Bambu Lab A2L, the Kobra X reduces purge waste by 47% and prints 19% faster. Compared to the Creality Spark Xi7, the Kobra X reduces purge waste by 22% and prints 22% faster. Although it is not as efficient as the dual extruder Bambu Lab X2D, the difference is not that large. However, a tool changer like the Creator 5 is still the best option for multi-material printing. I will do one more multicolor print, the Master Sword. This model is much taller than the others and has 876 color changes, which makes it a good reliability test. The estimated print time is 19 hours and 15 minutes. The print finished in 19 hours and 37 minutes, which is 22 minutes longer than the estimate. This time, the filament estimate was a bit off. The estimated purge waste was 253 grams, while the actual purge waste was 228 grams. The model weight and prime tower weight were still pretty accurate. Compared to the Bambu Lab A2L, the Kobra X reduces purge waste by 61%, and the print time is also 30% faster. Even though the A2L was using different filament colors, the 3MF file used the same green, blue, gold, and white colors in the slicer settings. Compared to the dual extruder Bambu Lab X2D, the X2D reduces purge waste by 68% compared to the Kobra X, since the second extruder can be used to print only the white color, which greatly reduces the number of filament changes. Once again, the Snapmaker U1 tool changer has zero purge waste and saves 60% of the print time compared to the Kobra X. I will then try some different materials, starting with PETG. I printed a tall trash can to max out the Z height of this bed slinger and see how it handles taller models. I printed this model with 3 walls, and it finished in 7 hours and 16 minutes. From a distance, the difference between the top and bottom is not very obvious. When zooming in under strong lighting, I can still see that the ringing near the top is not as good as near the bottom, but I would say this result is more than acceptable for tall prints on a bed slinger. Then I tried TPU, starting with 95A Eryone TPU. The machine actually confirmed that it can handle TPU through the multicolor filament system, so this should not be a problem. The TPU printed perfectly with 0 issues. However, out of curiosity, I also tried much softer 90A TPU to see what would happen. As expected, it had some extrusion issues. The 90A TPU is too soft to be pushed through reliably and jammed inside, so I do not recommend trying it. I also ran all my standard benchmark prints, including the number slider for the clearance test, the mini honeycomb box for the extruder retraction test, the simple geometry model for the tolerance test, and the Robo Alpaka for the surface quality test. Here are the results. The number slider printed perfectly in 2 hours and 48 minutes, which is an average time, but the tiles move smoothly. The honeycomb box printed in 2 hours and 29 minutes, also an average time. The result is clean, and even when compared with printers at higher price points, it is just as good as the others. For the tolerance test, the square side can clear up to 0.05 millimeters and stops at 0. The cylinder side can also clear up to 0.05 millimeters and stops at 0, which is a perfect score. The Robo Alpaka finished in 5 hours and 4 minutes. This is slower than the roughly 4 hours and 30 minutes I usually see from Core XY printers, but it is average for a bed slinger. Compared to the Bambu Lab A2L, the A2L is slightly faster and its surface quality is also better. Compared to the A1 is much faster, almost reaching Core XY level speed, and the surface quality is also better. Compared to the Creality Spark Xi7, the print time is the same, and the surface quality is also similar. Finally, I printed a PLA sheet to test the first layer. The sheet is almost perfect, with just a little over-squishing near the top left corner. it can be peeled off without any line separation. Even though some of the test prints showed a slightly over-squished first layer, this large first layer sheet printed almost perfectly and is more than good enough for regular prints. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The Kobra X integrates the AMS light into the print head, making the entire setup much more space efficient. Unlike the A1 or even the A2L, I would need to print a custom mount and install the AMS light on top of the machine if I wanted it to take up less desk space. 2. It has a much shorter distance from the filament cutter to the nozzle. As a result, much less filament remains inside the hot end and needs to be purged. This not only reduces filament waste by 40% to 60% compared to other AMS setups, but also makes multicolor prints significantly faster. 3. It's quiet. The printer stays below 50 decibels most of the time, and even during rapid movements, it only reaches the low 50 decibel range. This makes it one of the quietest bed slingers currently available. 4. The build quality is excellent. It's not just better than average, it's basically on par with Bambu Lab machines. Assembly is straightforward, and it prints well right out of the box. Overall, I would say this is a very beginner-friendly machine. 5. Some small details have also been improved. For example, the fragile filament sensor cable found on the A1 is no longer an issue. It's also easier to print with standard TPU, since you can feed it directly through the multicolor filament system instead of using an external spool and making special arrangements to bypass the AMS. Now for the cons. 1. Sometimes the purge-saving algorithm is a little too aggressive. On most other machines, you can simply select a similar filament color in the slicer, and the print will usually come out fine without any noticeable color contamination. On the Kobra X, however, you need to choose the filament colors more carefully to ensure the slicer calculates enough purge volume. 2. When printing in a single color, it is slightly slower than the A1 and roughly on par with the A2L and Spark Xi7, mainly because of its more conservative acceleration settings. Even though the wall acceleration is set to a slower than average 2000 mm per second squared, the surface quality is decent, but not the best among bed slingers. 3. It also has limited support for Orca Slicer. You can slice a model in Orca Slicer, but you cannot send the print directly to the printer over the network. Instead, you have to copy the file to a USB drive and plug it into the printer, just like the workflow from 5 years ago. 4. I noticed a few prints with a slightly inconsistent first layer, such as the 4-color square and Vegeta's brim. However, other prints, including the large PLA sheet test, came out perfectly fine. So I think AnyCubic still needs to refine the firmware a bit and further fine-tune the automatic Z offset. In conclusion, the AnyCubic Kobra X is not only an excellent Bambu Lab A1 clone. It not only performs better than the 3-year-old A1 in most areas, but also surpasses the latest A2L in certain aspects, such as filament saving and multicolor printing time. There is no question that this is one of the best entry-level multicolor bed slingers on the market. The only real drawback to me is the price fluctuation. As you can see, the price jumps up and down between $279 and $349 depending on when you buy it. So, if it is priced at $279, it is a no-brainer, and I can confidently recommend it to anyone. However, if the price is $349, it gets closer to the Creality Spark Xi7, which comes with an enclosed filament box, and it's also not that far from the Bambu Lab A1. The Kobra X still performed better than both of them in my testing, but at $349, its value advantage is not quite as appealing compared to the A1, especially since the A1 has a long-term track record of reliability. Anyway, due to its outstanding filament-saving performance, I will add the Kobra X to my recommendation list at AuroraTechChannel.com as the most efficient multicolor standard-size bed slinger. If you are interested in the Kobra X, I will add the link in the video description. Don't forget to also check out AuroraTechChannel.com, which monitors prices for popular 3D printers, laser engravers, and CNC machines to help you find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.